And here we are. Let's see if I can get that where I want it. And then we're going to start on this question that talks about we have a point outside of a circle. Let me draw a picture so you can see what it looks like. Here's a point, 8, 1. And we have a circle, x squared plus y squared, so my radius here is the square root of 20, or 2 root 5. And we want to find some possible slopes of the tangent line. So what we're looking for is that and that. So first thing I'm going to do is I'm going to start with my point slope form. And we're going to work our way to that formula that I gave you on the last that said from slope-intercept form. Okay? And let's go with y minus y1 equals m times quantity x minus x1, point slope form. And I'm going to put in the numbers that I know from that point outside, the 8, 1 point. So my y1 is there, there's my m, x minus 8. And I get that my slope is going to be this idea right there is going to be my slope. And I'm going to be using that here in a little bit. So let me go back and write that formula down for you. It said that d equals x sub naught, m slope times x sub naught plus b y sub naught all over the square root of 1 minus m squared. And that was on, hopefully you wrote that down, because the one that we used in the previous example was from standard form, and this is from slope-intercept form. And we're going to see if we can plug some of this in here. So let's get going. So I know that the center of my circle is at 0, 0. And let's plug in, my radius is root 20, so my distance, since we're going to the edge of the circle, my distance has to be the square root of 20 equals the absolute value of m times your 0, your x sub 0, and plus b, which is, we already have b. I don't know that I showed it here. Let me show you what b is. b is negative 8m plus 1. And that's that. And plus, let me make sure I get this right, plus negative 8m plus 1, and then my y sub 0 is also 0, all over the square root of 1 plus m squared, which was given to me. So, let me give myself some room so I can do some, first thing I want to do is simplify a little bit, so I'm going to say, give myself room here too, and that's going to go away, that's going to go away, and I end up with negative 8m plus 1 all over the square root of 1 plus m squared. Well, to make my life easier here, I'm going to square the whole world, and so I'm going to get 20 equals, let me FOIL this out because it's going to be that thing squared, 64m squared minus 16m plus 1 all over squaring the bottom gives me this 1 plus m squared. Let's multiply, so I get 20 plus 20m squared equals 64m squared minus 16m plus 1. Putting some like terms together, I get 0 equals, I might need a little more room yet, equals 44m squared minus 16m, and then I'm going to go with minus 19. And lucky for you guys, I spent a little bit of time trying to factor this, and I came up with 22m minus 19 m plus 1. And so my two slopes that I'm going to come up with are 19 over 22 and negative 1/2. Now let's go back up to the picture and take a look at, we got one positive slope and one negative slope. Well, this one from right to left has to be the negative 1/2. This positive one has to be the 19 over 22 slope. So that was kind of a trickster, but I got it. All right. So let's start on 11.2. A parabola is a set of all points equidistant from a fixed line and a fixed point not on the line. The focus is the fixed point and the directrix is the fixed line. Suppose for now that a parabola opens up and the focus is at some point 0p. So on the line, we'll call this 0p. And the directrix is the line y equals negative p. So if we have some line y equals negative p, we'll say it looks something like that. Let p be some xy, be a point on the parabola. So what we got going on here is all of these points, if this distance is whatever that is, the distance straight down there, those two have to be the same distance. So that distance and that distance have to be the same, and this distance and this distance have to be the same. So if we look at the equations for this, we get x minus h squared equals 4p y minus k, and that is for a parabola that opens up and down, and we have the side-to-side parabolas. May look like that, where h and k is the vertex. Okay, so the distance between the parabola and the directrix and the parabola in there is always distance p. So that's the distance p. All right. The axis of symmetry is the line that passes through the focus, is perpendicular to the directrix. The vertex of a parabola is halfway between the focus and directrix. That's why the distance both directions from that is d, or p we used in there. The axis of symmetry. So if I go back to my parabola, and I got the same on both sides, this is my axis of symmetry. Okay, and this would be my vertex, and this would be my focus, and somewhere down there would be your directrix, wherever it happens to be. All right, so let's talk about some of these, because there are lots of ways we can do this. So if I have a upward facing parabola, our equation is going to look like x minus h squared equals 4p y minus k, where the focus is at 0p, your directrix is going to be at negative p, and your axis of symmetry is at x equals h, the x value of the vertex. Now if it opens down, same dealio, we get x minus h squared minus equals negative, oh darn it, negative 4p y minus k, and 0, negative p is my focus, y equals p is the directrix, because that would be above it, and my x equals h is still my axis of symmetry. Now, if we have a right opening one, our equation is going to be the second one that I gave you earlier, 4p x minus h, and we get a focus at p0, and the directrix is the opposite direction, negative p, x equals negative p, and y equals k is the axis axis of symmetry. Now if it opens to the left, we're going to have the same equation, that's a k, squared equals negative 4p x minus h, negative p0, x equals p, y equals k, and not sure with the new book, but in the old book it was, I just copied that down from page 829. Alright, so let's take a look and determine the equation of parabola whose vertex is at the origin and the directrix is at y minus 8. Why don't we just call that y equals 8? And so if I have a picture of this, there's my directrix, and determine the equation of a parabola whose vertex is at the origin. So if it has a vertex at the origin, it must be going downward because it can't be going the same direction that the directrix is. And so if it's opening this way, and right there would be my focus at 0, negative 8, that'd be my focus. So the equation of this thing, since my vertex is at 0, 0, which is very important, I'm going to have x minus 0 squared equals 4, which is part of the formula. Now, since it's opening down, my p is going to be a negative 8, and then y minus k, again, we're 0. So my equation is simplified, it looks like that, where my h and k are both 0, so that makes it a little bit easier. A chord of a parabola is straight line segment that joins any 2 points on a parabola. A focal chord is a chord that passes through the focus. A focal width is the length of a focal chord that is perpendicular to the axis of symmetry. Okay. So let's take a look at a couple pictures here. Here's a very pretty looking parabola. I'm going to put a focus there. And I'm going to say that this is a focal, that would be a focal chord. And this is just a chord, because it doesn't go through the focus. And let's draw another picture here. And that would be my focal width. Simple enough ideas. Alright, so suppose that p is at 8, 8, that is on the parabola, x squared equals negative 8y. Let the segment PQ be a focal chord. Find the equation and length of the focal chord. Alright, so let's take a look at this. We know, boy, I don't have a whole lot of room there, do I? I don't know what I did there. Let's see if I can do it on top. So if I have the equation x squared equals 8y, we know that the 4 is part of our formula. So the 2 is the p. So if we know that the focus would be that distance, that's that p, from 0, 0, because obviously there's no h and k here. So I'm going to say that my p is equal to 2, my vertex is at 0, 0, my focus is 2 in the y direction, so going up 2. And if I have, so 8, 8 is on the parabola, and my focus is at 0, 2. And we want to find the slope of the line between those. So I'm going to use the point, that's my focus, because it's a focal chord, it has to go through the focus, and there's my point. So I'm going to get the slope of that, and I'm going to say 8 minus 2 over 8 minus 0, so my slope is